Welcome to Grade 11 Physics with Mr. Childs. So I will be using my website www.mrchilds.com for the primary communication of material, online lessons, tasks, etc. I will use Edsby for communication, handing in things, and I will use Microsoft Teams for our online content. Okay, so grade 11 physics. I have a couple rules. Rule number one, anyone can learn physics. And I mean that. Anyone can do this. Rule number two, physics is not math. Okay, but math is used as a tool to describe, compare, and study. So it's one of the languages or one of the components of physics that we use to talk about it. Rule number three, physics is a way of thinking and seeing the natural world around you. So we're going to be looking at relationships and those types of things. How things are connected, and yeah, it's really, it'll change the way you view the world. It's pretty cool that way. So if possible, if we're in person, then we'll do this in person, but if we're not, then we'll just do this either solo or we'll figure out a way to chat and text about it. I want to try and come up with some sort of idea or consensus for the following. And that's, what is physics? Okay, so if you want to pause the video, think about that, just jot down anything. Whatever works for you, just write her down. Okay, so hopefully you've had a chance to think a little bit about that. Normally we get answers like electricity and forces and things like that. And those would all be correct. There's actually no wrong answer. But what we'll start to see is, and these are just the three sciences we cover in chemistry or in high school. So biology is a study of organisms, ecology, those types of things. Chemistry is more about the structure and property, reactions of chemical elements. Physics, okay, is a study of matter, energy, space, and time. And this is the word I like to really work on, the relations or relationships between them. Okay, how things link together, how they interact is really important. And as you'll notice, that's a kind of a trend throughout all of the sciences. So if we were going to look at topics from a curiosity standpoint, the grade 11 Ontario curriculum, this is it right here. Okay, so we'll see matter, energy, systems and interactions, structure and function, lots of things. Okay, so kinematics, forces, energy, waves, electricity. Those are the big 5 topics we cover in grade 11. In grade 12, we move up to dynamics, which is moving things, energy and momentum, fields, both gravitational, electric, and magnetic, wave nature of light, and maybe we get into some of the higher modern physics, the quantum stuff, special relativity. That's all very time dependent. And just from an interest standpoint, I'll contrast that with the IB curriculum, and you'll notice it's pretty much exactly the same. Okay, so there's a lot of significant overlap between the IB curriculum and the Ontario curriculum. So we'll cover both at the same time, and hopefully we'll all come out as amazing little physicists. Okay, so we're going to look at some relationships. And we're going to start with a little bit of a mathematical conversation about it. And it's just, again, we're not going to concentrate on the numbers per se, but we're going to start looking at how things behave. And this might be a little bit of a different twist on math for you. So if I have an equation that says A equals B, so that means the quantity A is always equal to the quantity B. That's what this means right here. Okay? So what is the value of A when B is 20? Well, if B is 20, then A must also be 20 for this statement to be true. So, okay, that makes sense. What is the value of B when A is negative 12? Well, if A is negative 12, then for this to be true, then B has to be negative 12 as well. And most people are pretty comfortable with that. That makes a lot of logical sense. Now here's where it starts to get a little bit trickier. Describe the value of A when B is a large positive number. Okay, well, I didn't give you an actual value. I just gave you a description. So what happens to A when B becomes a large positive number? Well, A becomes a large positive number as well. Okay, and I'm just cheating with some shortcuts. Describe the value of B when A is a very small negative number. Now see, this one's tricky because there's some semantic issues here. When we talk about a very small negative number, let's just pop over to a number line here. This is -1, -2, 1, and 2. This can be a little bit confusing for some people. Technically, if we were getting smaller, we would be moving to the left. So from 2 to 1, that's smaller. 1 to 0, that's smaller. Technically, from 0 to -1 would be smaller. But what we start to have to talk about is the magnitude of the values. And so we'll change some of our language for that. So if I describe the value of b when a is very small in magnitude, so I'm meaning close to 0. Okay, so we're looking at small numbers close to 0. Okay, and it happens to be negative. Well, in this case, a would have to be a very small negative number. Because they're equal, it has to match what b is, so they would be the same. Okay, this is called a directly proportional relationship. You may have heard that in grade 9. An increase in one value results in an increase in the other. Okay, same with a decrease. All right, so let's try a slightly different version. Now this equation is a little bit different. A equals 1 over b. So they're no longer exactly equal. Now they have a different relationship. Okay, so what is the value of a when b is -2? Okay, well, what is the value of a? There's a, and it's going to be, if I replace the b with a -2, so the value of a when b is -2, a must equal to -1/2. See, that's a very different response than the first question. The first question, they were both the same. Now they're different. So what is the value of b when a is 0.1? Okay, so if this is 0.1 for a, and this has to work like this. Now, if I have 1 divided by something, and it has to turn into 0.1, there's lots of ways to solve this little equation. We could just do a little bit of thinking, though. I need to divide 1 by something bigger than 1. Okay, so I have to divide by, in this case, 10. So 1 divided by 10 would be the same as 0.1. So b would have a value of 10. Okay, so describe the value of a when b is a large positive number. Now this is where it starts to get a little trickier. So if we look at a, here's our relationship. If this b on the bottom gets really big, and if you want to try a couple of numbers in a calculator just to test the idea, try 1 divided by 1,000, 1 divided by 10,000, 1 divided by 1,000,000, and you'll start to see the trend or the behavior of a. So what happens is when b becomes a large positive number, a becomes a very small positive number. Okay, so the bigger the number you put in for b, the smaller a is going to end up being. Okay, describe the value of a when b is a very small in magnitude and a negative number. So we want to look at what is the value of a if we let b, right here, so this guy is going to be very small and negative. Well, the first thing we should know about a is that that will make a negative number, because we'll have 1 divided by a negative, so a will become negative for sure. We know that part. And now here's the tricky part. If you have 1 and you divide it by very small numbers, and you can try this down on the bottom, you can try this on your calculator, convince yourself and see what happens. So if you divide 1 by these really small numbers, what we find, because this is division and it's asking me how many of these really small numbers fit into 1, we find that a starts to get really big. So we would have a as a negative number, and it would start to get large in magnitude. Okay, so something like here, this would become, if we're going to do this correctly, actually let's get rid of that. This would just become a 10. 1,000, 10,000, or 100,000, however many zeros there are, and they would get progressively larger. So again, we're not really interested in the exact number. What we're interested in is how it's behaving. Okay, now this is called an inverse proportion. Okay, so an increase in one value results in a decrease in the other. So this is backwards to the proportion one. Okay, so what if we mix things up here a little bit more? What if we have multiple letters or variables? So for the equation A equals B times C, determine the following. So what is the value of A when B is 4 and C is 5? Okay, now that's not too bad to handle. We can multiply those together and we get a nice clean value of 20. What is the value of B? Okay, so we're looking at for the middle term when A is 1,000 and C is 100. Okay, so you'll notice we have to at least provide 2 out of the 3 unknowns to be able to solve for one. So in this case, we'd say B is equal to 10. Again, a nice number value. We're normally pretty comfortable with those. Now here's where it gets a little fishy. Describe the value of A. Okay, so we're describing. That means you can't actually calculate this. Describe the value of A when both B and C are large positive numbers. Well, if you multiply 2 large positive numbers together, A is going to become a very large positive number. Okay, and again, there's no actual calculation to make. We just have to sort of know, 2 big numbers multiplied together makes a bigger number. Perfect. Describe the value of A, okay, when B is a large positive number and C is a large in magnitude negative number. Okay, so we're trying to describe the value of A. So now we have A is going to be a large positive number times a large negative number. So what we should end up with, running out of space here, A is going to be a very large in magnitude, but it'll be a negative number. And again, we don't need the numbers to calculate it. We just have to look for the behavior. Lastly, describe the magnitude of A when B is a constant. Oh, interesting. Okay, so we have A equals BC. If we lock B in as a constant value, okay, so it's not going to change. If it's not going to change, okay, then it's one less thing to worry about. And C is decreasing toward the value of 0. Okay, so if this guy is constant, the B, and C is heading towards 0, for this to maintain equality and be equal, the only way it could do that is if A decreased towards 0. So A would have to decrease towards 0. Okay, and again, this is just looking at behaviors and relationships. It's just a way to get our minds stretched and expanded. Hopefully it doesn't make you too upset. Let's go over a few grade 9 concepts real quick though. A line passes through the points A, 4, 6, and B, -2, -6. Let's give ourselves a little more room here. So I'm going to plot those 2 points. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Reminder, Y is on the vertical, X is the horizontal. These are X's and Y's. They're alphabetical. -2, -6. So here's A, and here's B. So what is the slope or rate of change of that line? Okay, so if I grab the line tool here, let's make it a little smaller so it's not so too obnoxious, and we'll make it blue. Okay, we could do something like that. Correct this end here a little bit. Now the slope or rate of change, you might remember the term rise over run, those types of things. If I create a large triangle here, I can get the rise and I can get the run by finding out the difference between them. Sometimes you can count squares, sometimes you can't, depending on the scale. This one, the scale is 1 to 1, so I can count squares. 1, 2, 3, 4, 5, 6. 6 is the run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The rise is 12. So our slope, or our rate of change, m is used for slope, would be 12 over 6. We could reduce that to 2 over 1. And what we should find is that anywhere on this line, this linear relationship, if I go up 2 and right 1, I land back on the line. Okay, so that slope is constant throughout the entire linear relationship. So our slope is 2 over 1. What is the y-intercept of the line? Okay, well the y-intercept is where the line crosses the y-axis. It's this location right here. And it would have a location of 0, -2. And then lastly, what is the equation of the line? Usually we work with equations in the form y equals mx plus b. And a quick refresher, that's your rate of change. B is your y-intercept. So if we can find those two pieces of information from the graph, we can just write our equation as y equals 2x minus 2. And that would be the equation that describes this linear relationship. Okay, lastly, we'll go over a little trig. So SOHCAHTOA and Pythagorean theorem. So SOHCAHTOA, you might remember sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. And the SOHCAHTOA part, those are just little short forms on how you can keep track of what ones go together. The opposite and the adjacent are entirely dependent upon what angle you choose to solve for. So if I choose that angle there in the bottom right corner, then this becomes opposite, this becomes adjacent. If I had chose the top angle, those would flip. Okay, so in this case, let's find the hypotenuse first. We could do a quick Pythagorean theorem. So we would have leg squared plus leg squared. This is the way I write this. It's going to seem a little strange at first. But the legs are these two pieces. They're attached to the 90 degrees. I don't fall in love with the a squared plus b squared equals c squared thing because too many people can mix it up. So I would have 10 squared plus 16 squared equals h squared. So that's 100 plus, I want to say 256, but I'm going to double check because I'm recording. 256, awesome. Okay, I can bring those together. And then to undo a squared term, I square root both sides. And I end up with 16, ooh, that didn't do that right. 356 square rooted 18.9, that sounds better. So now I have 18.9 equals my hypotenuse. And I do a quick check. It's bigger than both of the legs, so I know it's a reasonable answer. Okay, I'm going to move to finding the angle. So to find the angle, I'm going to use the given information of the opposite and the adjacent. So if I have opposite and adjacent, I'm going to use tan. Okay, so I'm going to say tan theta equals 10 over 16. And then I'm going to arctan. That's the proper term for undoing a tan. So on your calculator, make sure you're set in degrees or you might get some surprising answers. Okay, so we take our 10, we divide it by 16, we hit equals, we go second function, tan, which invokes the arctan, and we should get 32 degrees. So we can fill this in as 32 degrees. Once we have 2 out of the 3 angles, this little square is at 90 degrees, we can subtract them both from 180, and we get our missing third angle, which in this case is 58 degrees. Okay, I'll leave the last one for you to try. Thanks for tuning in. Much appreciated.